easiest way to use Model Builder is to use one of biointeractive models for educators that is on the landing page for the Model Builder tool. If you need help with Model Builder, you can always use the user guide or pedagogy guide, and that has a wealth of information in there for how to use Model Builder in your classroom and just how to use the tool in general. So let's start the tool. And here is a list of around 50 models that are in Biointeractive to cover a standard biology curriculum. And Biointeractive is actively working to add more models into the list. So let's take a look at one of these models. There are two types of models. There are conceptual models, which just have positive and negative connectors and neutral connectors, and stock and flow models, which have different objects. They have stocks, which are like reservoirs, flows, and also variables. Okay, but for now, let's just look at a conceptual model. So I'm going to click on this carbon cycle model. So I'm going to open it up, and let's see here. When we open it up, we have this workspace here, and we're going to drag the models into that workspace. So I'm going to just drag the different objects in here. And then I'm going to go through, I can read what are the major assumptions of the model. So carbon in the atmosphere and carbon in the biosphere represent reservoirs of carbon. Photosynthesis and respiration are processes by which carbon moves from one reservoir to another, and sunlight is the energy from the sun entering the system. And then let's look at the instructions. So in the instructions, you're to add connectors from the processes to the reservoirs to show how each process affects the respective reservoirs. So while it's called a carbon cycle model, we're really looking at how are we to show how the processes affect the reservoirs. Okay, so let's take a look on how to build these models. So carbon in the atmosphere. Let's see, what does respiration do to carbon in the atmosphere? That process is going to increase carbon in the atmosphere, and respiration is going to decrease carbon in the biosphere. And then I can check, and we have 3 mistakes. Let's see what those mistakes are. We have missing connectors. That's okay, because we still have not connected these variables over here. If we were to put in a incorrect connector, so for example, if we said this, and let's check this, a little red dot is made, which is going to indicate that that connector is wrong. So we have 1 connector mistake, and we have 3 missing connectors here. Now let's talk a little bit briefly about what it means to be a positive connector and a negative connector. So what I really mean by this positive connector here is respiration causes carbon in the atmosphere. So if we have respiration, for example, on our x-axis, and atmospheric carbon on our y-axis, respiration causes that. And how does it cause it? It is increasing it. So think of it as having a positive slope. So as the respiration is low, carbon in the atmosphere will be low. And when respiration is very high, carbon in the atmosphere is going to be high. So there's a positive relationship or a positive slope to that connector. And respiration produces carbon into the air, so that is why we have a positive connector going there. Now, let's look at this one here. We're going to get rid of that connector, and I'm going to put a negative connector there and hit check. And what's nice is it's checking this model against a reference model. So what does a negative connector mean? Well, a negative connector, respiration is our cause, or our independent variable, and carbon in the biosphere is our dependent variable. Just to be clear, just because two things are correlated doesn't mean they are causative. But in this case, this is what our model is showing, is that really respiration is causing carbon in the biosphere. And how is it doing that? Well, we're saying it's a negative relationship. So that if our respiration is low, carbon in the biosphere will be relatively higher. And if our respiration is really high, carbon in the biosphere is going to be relatively lower. Because respiration, think of like a plant here. When a plant is respiring, carbon is going out of the plant or biosphere and going into the atmosphere. So as respiration is really high, we're losing carbon out of the biosphere. Okay, and now let's build the rest of this model. So what does photosynthesis do? And we can have hints here. Oftentimes I'll have students turn the hints off as it kind of clutters our workspace here. But photosynthesis has a positive effect on carbon in the biosphere. It's taking carbon out of the atmosphere and putting it into plants. That's how they're building their mass, is through photosynthesis. And photosynthesis is decreasing carbon in the atmosphere. It is taking carbon out of the atmosphere and putting it into plants. Okay, and then lastly, how does sunlight affect this model? Well, it's affecting photosynthesis. And how is it doing that? Well, the more the more light there is, the faster photosynthesis there is. And we can check our model and we have 0 mistakes found, which is what I have my students' goal to be. And then I'll have my students show me that their model is complete. As they go around though, what's nice is I can have students incorrectly building models, which they're just struggling to try to interpret what does the model mean and what is happening. And as they check their model, I can go around and intervene with them, ask questions, help them scaffold what they know with what the model is intending to try to help them be successful with the model. Then, once the model is made correctly, we can also ask questions about the model and how to interpret the effects of the model. So for example, if I could ask, I could ask, do the connectors accurately illustrate the movements of carbon? So does this little connector here accurately portray what happens? As photosynthesis increases, does carbon in the atmosphere decrease? And it does. The more photosynthesis, the more that's going to lower carbon in the atmosphere. Also, we could ask questions like, what are some other variables What are some other variables that might affect the processes or reservoirs? So we can think about how could we expand this model is another way I will work with models in the classroom. So that's an introduction to conceptual models. I'll make another one for the stock and flow model of the same system, carbon cycling. I hope you found this model useful.